Hi everyone. Hi Himanshu. Hi Nand. Hope you guys can see me and hear me. You can use the chat window which is given to you on the bottom right. Okay. So essentially what we are going to do today is primarily going to discuss this finding out the last digit and the last two digits for a particular number and how exactly we can do that. That's the, so to say, the fundamental goal for today's session. Now, while we discuss this, before we even go ahead with that, it's really important to understand why is this relevant. So what happens is sometimes you get direct questions on it. Okay, let's say a longish number is given and then you are asked to find out the last digit for it or the last two digits for it. And in many cases, what also happens is that you are asked to, uh, figure out the last digit, last two digits, just to get to the actual answer. So that is another one of the methods or ideas which is used to figure out the last digit or the last two digits for something like this. Now, going ahead with this, I'm Ravi Handa. I have done my studies from IIT Kharagpur, and since for the last 15 plus years, I have been teaching for CAT. I have taught 20,000 plus students online via a website called Funda that I used to run. A few days ago, I joined Unacademy, and from now on, I will be teaching purely on Unacademy for the near foreseeable future. Now, with that in mind, suppose you are trying to, get in touch with us. If you have any doubts, any ideas that you need help with, you can go ahead and join our channel on Telegram, which is the Cat Prep online channel, which will help you prepare for it. It's a group. You can ask your questions over there as well. You should be able to find it fairly easily on the on Telegram. Now, moving ahead with this, Unacademy actually gives you options for two types of courses, the plus courses as well as the iconic courses. In the plus courses, you get live classes such as this one, but they are not just randomly live, but they also have, structured courses. So it'll not be randomly that, okay, I'm teaching a particular topic right now, I'll be teaching another topic a little bit later. That's not how it works. But what will fundamentally happen in cases like this is, one second, guys, I'll put my phone on silent. Okay. Yeah. So what happens is you get access to structured courses. So that means you will get the courses in a particular fashion, that first you need to do this topic, then you need to do this topic, then you need to do this topic. And that way it helps you plan and prepare better. So that's why it is recommended. The iconic courses give you personalized guidance, so they can tell you which areas you are good in, which areas you are bad in, and how you can actually improve in those. The subscription for the Plus course is for 12,600 rupees for a period of 6 months, assuming that you use the coupon code HANDA. For the iconic course, it is for 27,000 rupees. The zero is missing from here. Once again, this is after a 10% discount, provided you use the coupon code HANDA for it. These new prices are actually going to be effective from the 31st of March. They are not going to, remain what they are right now. So in case you're planning to register for any of the courses, I would strongly recommend that you do that registration now itself and not wait for 31st March or beyond. Because if you do that, what will happen is that the prices are going to be raised and might not be a good idea. Now, going ahead with how do you actually solve questions like this, the first case that you need to consider is with these four numbers, which is 0, 1, 5, and 6. Just give me a minute, guys. Yeah. So as I was saying, the first case that you need to consider is when the last digit of the number ends in 0, 1, 5 or 6. For example, when you are given a long number which is ending in 0 and it is raised to any particular power, the last digit of the end result will still end in 0, will still end in 0. So if you have to find out the last digit, then you really don't need to put in too much effort. What you can simply do is, if it is a 0 here, then it will be 0 here. There is no calculation which is required. Very similarly, if you have a number which is ending in 1, it doesn't matter, which power is given over there. Whichever power you provide, the answer will still be with a digit ending in 1, so you don't really need to do anything. Very similarly, if you have a number which is ending in 5, you raise it to any particular power, does not make a difference. Once again, your end result would be that the number ends in 5 and nothing else is required, nothing else is needed. Similarly, for a number which ends in 6, raise it to any power, it will still end in 6. So for these four cases, that is for numbers which are starting with 0, 1, 5, or 6, there is nothing else or nothing extra that is required that you need to do in these cases. All you need to do is look at the last digit for the initial part, and that will lead you to the final answer. Are you guys okay with this particular case? Okay, let's go ahead. Uh, Varshit is the one who just joined us. Varisht or Varshit. I'm just going to call you Naidu. So, Naidu, we just started with finding out the last digit. The only point that I have made is that when you are trying to find out the last digit of a number, if it ends in 0, 1, 5, or 6, you raise it to any power, it will end in 0, 1, 5, or 6. Hope you are okay with that. Let's move on to a slightly more complicated cases. What are you going to do when you have a number which ends in 4 or a number which ends in 9? So these are the cases that we will need to be, kind of a little bit careful about. So, Varshit, will you like to give me a number? Any of you like to give me a number raised to another power such that the last digit of the number is 4? Would you like to give me a number such that the last digit of it is 4 and it is raised to another power? Varshit, Himanshu, Gaurav, any such number, and I'll take an example of that and we can take it forward from there. So just any number that you can give me. Welcome Ritik, welcome Kishore. 18679, and what power do you want me to raise it to? Gaurav? 4569. Okay. So suppose you are trying to find out 18769 raised to the power of 4569. What is going to be the last digit for this? This is what you are trying to find out. So now your fundamental goal is 9 to the power of 1 is ends in 9. 9 square is effectively 81. So it ends in 1. 9 cube is 729. So it ends in 9. 9 to the power of 4 is 6561. So that it ends in 1. So 9191, that is the pattern that is being followed. So if there is a number which is ending in 9 and it is raised to any power, I can very clearly say that it will end either in 9 or in 1. And if you want me to be more specific, I can very clearly say 9 if it is raised to an odd power. As you can see here, 9 to the power 1 or 9 to the power 3, these will end in 9. And if it is 9 which is raised to an even power, then it will end in 1. As you can see here, 9 to the power 1 ends in, sorry, 9 even power is 81, so ends in 1. Power is 4, so it ends in 1. So that's the case for 9. Now, Harshit has joined us, Kishore M. Would you like to give me, Kishore and Harshit, would you like to give me a number which ends in 4 and then raised to any other power? So give me a number which ends in 4 and raised to another power. I'll try to, tell you what the last digit would be. Any of you? If you can give me a number which ends in 4 and is raised to a power, I can tell you what last digit it would be. Abhishek Tiwari has joined us. Hi, Abhishek. Gaurav says that the number is 23564. And what power do you want me to raise it to, Gaurav? 444. Okay. So once again, let's do that. Fundamental idea when you are trying to find out the last digit, when you are finding, good morning, sir. Good morning, Abhishek. I am good. So what we are trying to do is we are trying to find out the last digit for this particular number. So 2356 don't really matter. We are only concerned about what is the last digit. So let's try. 4 to the power 1 ends in 4. 4 square is 16. So it ends in 6. 4 cube is 64. So it ends in 4. And finally, 4 to the power of 4 is 256. So it ends in 6. So as you can see, the pattern that is being followed in case of 4 is there are just two values, or it has a cyclicity of 2, which keeps on repeating itself. So this is 4 and 6, and that's the pattern which is repeating. Once again, I can very easily or very clearly say that if it is 4 to the power of an odd number, if it is 4 to the power of an odd number, then it will end in 4. As you can see, 4 to the power 1 ends in 4, 4 cube ends in 4. And if it is 4 to the power of an even number, then it will end in 6. So we have 4 to the power of an odd number and we have 4 to the power of an even number. One of them ends in 4 and one of them ends in 6. Applying the same idea here, what we had was 4 to the power of 444. So now I have 4 to the power of an even number, and 4 to the power of an even number will end in 6. Are you guys okay with this? 4 to the power of an even number ending in 6. Siddharth Mahajan, Saloni, Vishal, welcome to the class. Can I go to the next case? So we have discussed two cases till now. For the numbers which are ending in 0, 1, 5, and 6, they will continue to end in 0, 1, 5, or 6. Whatever powers they are raised to does not make a difference. The other cases that we have discussed is when the numbers are ending in 4 and 9. Those are the other cases that we have discussed. Moving ahead with this. Last digit of a to the power n when you have numbers or the bases which are ending in 2, 3, 7, or 8. So let's look at them one by one. 2 to the power 1 ends in 2. 2 square is actually 4, so it ends in 4. 2 cube is 8. 2 to the power 4 is 16, or it is 6. And after 16, if you multiply 16 with 2, what happens? 16 into 2 is 32. So after this, you come back here, or the cyclicity comes out as 2, 4, 8, and 6. So that's the cyclicity for 2. How are we going to use it? I'll tell you that later. My first job is I'm just trying to find out the cycles or the numbers which are possible. For example, in case of 4, the numbers which were possible were 4 and 6. We first found that out, and then we figured out the logic that it has to be 4 to the power odd or even. So I'm doing the first step now for 4. Let me try and do the same things, the same logic for 3. So 3 to the power 1 is 3. 3 square is 9, so it ends in 9. 3 cube is 27, so it ends in 7. 3 to the power 4 is 81, so it ends in 1. 81 into 3 will be 243. So once again, after 81, you will go back to 3. So the cycle for the cycle of numbers which 3 powers of 3 can end in is 3, 9, 7, and 1. So those are the various powers which are possible here. Let's look at the next case, which is for 7. So 7 to the power of 1 ends in 7. 7 square is 49. So it actually ends in 9. 7 cube is how much? 7 cube is 49 into 7, so 28. So 343. So it ends in 3. 7 to the power 4, 49 square, 25 minus 1, so 2401. So now after this, if you multiply, again, it goes back to 7. So the cycle that we were looking for 7 is 7, 9, 3, and 1. So now we have obtained the cycle for 7 also, and we have obtained the cycle for 2 and 3 also. And then finally, let's have a look at the cycle for 8. 8 to the power 1 ends in 8. 8 square is 64. 8 cube is 512. And 8 to the power of 4 is 4096. So the cycle that we are looking for 8 is 8, 4, 2, and 6. So these are the cycles that we are looking for. But what do I actually do with a cycle? How do I actually calculate an answer? And for that, I will need your inputs. I will need your help. Let's try and find that out. Okay, now this. Give me a number which ends in 2, 3, or any of those. Give me a number like that. Anyone? Give me a number which ends in 2 raised to any power. So none says, and none, what do you want me to raise it to? 14582 raised to what power? 14582 raised to what power? Just 1 second, guys. Yeah, sorry. So you want me to raise it to 257. Now, please note, as long as we are trying to find out the last digit, the only thing matters is what is the last digit of the base. So the last digit of the base is 2. So that is the only thing that I am going to care about. The 1458 before it is of no significance to me. Another thing is that since the cyclicity of the powers of 2 in case of last digit is 4, so all that I need to do is I need to find out whether this 257 is a multiple of 4 or if it is a format of 4k plus 1. Because if it is 4k plus 1, then my answer is 2. If it is of the format of 4k plus 2, then my answer is 4. If it is of the format of 4k, a multiple of 4 or 4k plus 3, then my answer is 8. And if it is of the format of 4k, yani ki it is a multiple of 4, then my answer will be 6. This is the cycle. 2, 4, 8, and 6. So the only thing that I care about is that what is happening in power with respect to divisibility by 4. With respect to divisibility by 4. So the only thing that I care about is in the power, I only care about divisibility by 4. So in the power, I will only care about the last two digits, which is 57. Now, once I have figured out that the last digit is 57, the only thing that I care about is 57 can be written as a multiple of 4 plus what? 56 is divisible. So 2 to the power, so 57 is a multiple of 4 plus 1. So this becomes 2 to the power of 4k plus 1, making the last digit or the answer that I'm looking for as 2. Let's try a couple more. Saloni, no, the answer is 2. Give me another number such that it ends in 2378 raised to any power. Give me a number such that it ends in 2378 raised to any power. Please tell me and I'll try and explain that. 247 to the power of 45. Okay, let's try that. 247 to the power of 45. First of all, the only thing that matters in the base is the last digit. The only thing that matters in the power is 45 or the last two digits of the power. So this is of the format of 7 to the power 45. So 7 to the power of 4k plus 1. What is the cycle for 7? Cycle for 7 is 7, 9, 3, and 1. So it will, since it is 4k plus 1, it will be the first value in the list, or my answer will be 7 here. My answer will be 7 here. Let's have a look at another one. Siddharth Mahajan is saying 4, 5, 9, 8, 7, which is raised to the power of 3, 4, 9, 0, 1. Once again, only thing that matters in the base is the last digit. Only thing that matters in the power are the last two digits. 7 to the power of 0, 1. So this is as good as 7 to the power of 4k plus 1, which means once again in the list, I will have to look at the first value and get my answer as 7. 7. Saloni 7 comes out as the answer for this because it is of the format of 4k plus 1. Remember, in your list, which was 7, 9, 3, 1, 4k plus 1, first value is the answer. 4k plus 2, second value is the answer. 4k plus 3, third value is the answer. 4k, 1 is the answer. Let's do one more. I think Saloni is still getting confused with it. Give me any other number raised to any other power. Any number raised to any other power. Okay, so Saloni says 353 to the power of 567. Now, in this case, in the base, what matters? Only the last digit. In the power, what matters? The last two digits. So they are 67, which means 3 to the power of 67. Now I need to write this as 3 to the power of 4k plus something. So divide 67 by 4. 64 is divisible. So a multiple of 4 is 64. 64 plus 3. 64 plus 3. So this is 4k plus 3. What is the cycle for 3? The cycle for 3 is 3, 9, 7, and 1. That means now it is 4k plus 3. So I will look at the third value in the list, or my answer will come out as 7. Are you guys okay with this? So I will just quickly recap what we have done till now. First case, when the numbers are ending in 0, 1, 5, or 6, no calculations required. Directly you can say if it is 0, answer is 0, 1 is 1, 5 is 5, 6 is 6. Second case is when it is 4 or 9. In case of 4, you can get two answers, 4 or 6. When the power is odd, you get 4. When the power is even, you get 6. In case of 9 also, you get two answers when the power is even or the power is odd. And finally, the last case where these were the cycles which were obtained. And depending upon the cycle, we took a few examples to explain how you can actually calculate this. But to be honest, it's kind of rare that you will get a direct question as simple as what we have discussed till now. The kind of questions that you are going to get in the exam are going to be something like this. So please try and find this out. Please note that this is 122 factorial. Do you guys know what a factorial is? What is n factorial? N factorial is the number n into n minus 1 into n minus 2, and this goes on effectively till 3 into 2 into 1, and that is what your n factorial is. So if someone wants us giving you a question 1273 to the power of 122 factorial, so think about how big a number it will be. So you are right about that Saloni, it's 121 into 121 into 120 and so on. Please tell me what will be the answer here. Anyone? Please tell me what do you think will be the answer here. Saloni, Siddhant. Should not be very difficult. Let me know if you can come up with an answer for this. Siddharth says it is 3. Kishore says it is 2. Anyone else with an answer? Kishore, it cannot be 2. You have an odd number in the base. See, Kishore, the first thing that you should realize is that this question is of the format of 3 to the power of 122 factorial. So if it is 3 to the power of something, then your answer can only be 3 or 9 or 7 or 1. You remember the cycle that we had obtained for 3, 3971. So this is the only possibility, nothing else is possible. So if you're thinking beyond this, then you are essentially making a mistake. Nothing other than 3971 is possible here. So now since you have obtained 3 to the power of 122 factorial, that is what you are trying to find out. So this is 3 to the power of a multiple of 4 plus something. So the question effectively that you are trying to answer is 122 factorial. When you divide by 4, what is the remainder you are going to get? 122 factorial, when you divide by 4, what is the remainder that you are going to get? So it is 122 into 121 into 120. You write it down till the end, such as 3 into 2 into 1. And when you divide this entire thing by 4, what is the remainder that you are going to get? Well, fairly simple and fairly straightforward. Since 120 and 4 will cancel out, your remainder is going to be 0. That means the number that you have is of the format of 3 to the power of 4k plus 0, or in simple terms, it is 3 to the power of 4k. So if it was 4k plus 1, answer would have been 3. If it was 4k plus 2, answer would have been 9. If it was 4k plus 3, answer would have been 7. Since it is 3 to the power of 4k, the answer will be 1. Are you guys okay with this? 1 is the answer for this one. Siddharth is right. Kritika also got it. Good enough. Let's move ahead to slightly more complicated question on the exact same topic. Now you need to find out the last digit when you have 1 factorial plus 2 factorial plus 3 factorial and it goes on till 19 factorial. How will you calculate this? Still dealing with factorials, still trying to find out the last digit. How are you going to calculate in this case? Now, for those of you who don't know, let me help you with some of the values. 1 factorial is simply 1. 2 factorial is 1 into 2 into 1, which is 2. 3 factorial is 3 into 2 into 1, which is 6. 4 factorial is 4 into 3 into 2 into 1, or 4 into 3 factorial, which is 4 into 6 or 24. 5 factorial is 5 into 4 into 3 into 2 into 1, or 5 into 24, which is 120. 6 factorial is 6 into 120 or 720. 7 factorial is 7 into 720, which comes out as 5040. 8 factorial is 8 into this, so that will be 40320. So 40320, and I'm sorry, I cannot calculate 9 factorial because it is, as you can see, it is becoming more and more complicated. It is becoming more and more complicated. The question that I'm asking is, what will happen when you keep on going like this till 19 factorial? What is the answer that you are going to get in that particular case? Saloni says that the answer is 3. Is there anyone who agrees or disagrees with Saloni? Okay, let's check. So what will happen is, please note that when I'm finding out the last digit of k, I'm not concerned with the full numbers. I'm only concerned with the last digit. So instead of considering 1, 2, 6, 24, 120, 720, 5040, and 40320, I will just be bothered with what is the last digit. So what is the last digit for 1 factorial? 1. What is the last digit for 2 factorial? 2. What is the last digit for 3 factorial? Since it is 6, it is only 6. Last digit for 4 factorial? I am not bothered with it is 24. I am just want the last digit here. It is 4. Last digit for 5 factorial? 0. Last digit for 6 factorial? 0. Last digit for 7 factorial? 0. As a matter of fact, if you keep on continuing with it, the last digit for 19 factorial will also be 0. So what is my overall value? 1 plus 2 plus 6 plus 4, which is effectively 13. But I don't want 13. I just want the last digit. So the last digit in this case will come out as 3, which is what I believe Saloni had indicated a little while earlier. Are you guys okay with this one? Okay, let's go ahead. Welcome, Gagan. Let's try even something slightly more complicated. Please try and solve this one based on the exact same concepts that we have been discussing till now. Exact same concept that we have been discussing till now. Let's try and solve this one. Once again, please write done when you are done. Siddharth says it is 1. Okay, Siddharth. Anyone else with an answer for this one? Gaurav says it is 9. Saloni says it is 0. Okay. Kritika also says it is 0. Let's check. Let's check. So I will like to go back to, when we were discussing these questions. So when I said I have a number which is raised to a power, when I am trying to find out the last digit of something like this, what matters? What matters is the last digit of the base and the last two digits of the power. So in this question also, what is going to matter is, so suppose I have n is a very big complicated number. So n is x to the power of 40. So if somehow I can find out the last digit of x, if I can find out the last digit of x, I will raise it to the power of 40 and my job will be done. So first of all, when I have the value of x as 1 factorial plus 2 factorial plus 3 factorial till 1000 factorial, my job is to find out the last digit for x. What will that be? 1 factorial will give me the last digit as 1. 2 factorial will give me the last digit as 2. 3 factorial will give me the last digit as 6. 4 factorial is 24, so last digit as 4. 5 factorial will give me the last digit as 0. 6 factorial will give me the last digit as 0. 7 factorial will give me the last digit as 0. And till 1000 factorial, all of them will give me the last digit as 0. So overall, my number will come out to be 13, or the last digit that we are looking for will come out as 3. As a matter of fact, since this was 19 factorial, my answer came as 3. If instead of 19 factorial, I went till 20, 21, I went till 1000 factorial, it would still have been 3. Because whatever factorial that I'm adding after it, it doesn't change. It doesn't change the fundamental fact that after the first four values, whichever factorial you take, it is not going to make a difference. So I got last digit of x as 3. That means my question is not now x to the power of 40. My question is now 3 to the power of 40. My question is now 3 to the power of 40. Okay, one thing which in case is not obvious, let me just clarify that part as well. What is the remainder of 357 from 10? It is 7, just the last digit. What is the remainder of 1, 2, 8, 9 from 100? It will be just the last two digits. So there is no need to calculate when you are finding out the remainder from 10 or from 100 or from 1000. If it is from 10, it is last digit. If it is from 100, it is last two digits. There is nothing else or nothing extra which is required. So if divided by 10, instead of this, I can very simply say, what is the last digit? And that is what we are trying to find out here. So for 3 to the power of 40, this is effectively 3 to the power of 4k. Let us go back to the cycle of 3. Where is the cycle of 3? Here. So 3 to the power 1, 3. 4k plus 2 is 9. 4k plus 3 is 7. And 4k, that is a multiple of 4, will actually give me the last digit, as I believe a few of you have indicated already, as 1. Are you guys okay with this? So Siddharth, Kritika, they are fine. Let me go ahead with this. But till now, what we were, kind of discussing were the last digit ideas. Now, what I'm going to do is full screen for the video. I'm not sure what that means. No, this is zoomed too much. Okay, I'm back. Yeah, so when the last digit is 5, what do you do in that case? For my face, I can see that as a corner in the rectangle. I'm not very sure how to change that particular setting. Anyways, Kritika, there is nothing really with the face here, even if it's not full screen. Hopefully, you will be able to understand. So let's focus on the things at hand. The last two digits, when the last digit is 5, the only case, the only case in which it is 5 can lead to only two scenarios. What are those two scenarios? That either it will end in 25 or it will end in 75. These are the only two ways or the only two possible solutions for the last two digits when the last digit is 5. Let me take an example for this. Once again, Saloni, Kritika, I will ask you to give me a number which ends in 5 raised to any power. Give me a number which ends in 5 raised to any power. So Saloni wants me to calculate 465 to the power of 678. So this is what we are trying to do. Now, focus on something. What do we need to do here? We need to find out the last two digits. So whether it is 465 or 1465, it doesn't matter. The only thing that matters is whether it is what are the last two digits of the base. So which is 65. And in the power, the only thing that matters is what is the power or what whether the power is odd or even. And here what is happening is the power is even. And even before that, let's not do that. So let's try. So what is 65 into 65? Please remember, I want only bothered about the last two digits. So 5 into 5 is 25. 5 carry over 2. 5 into 6 is 30. So 32 here. And then 6 into 5 is 0. 30. So this comes as 25. So this is essentially what 65 square will end in. Now, if I multiply it with 65 again, let's see what happens. I get 25 and then cross again 0. I again get 25. So do you notice something? What is happening here? 65 cube will also end in 25. So 65 square ends in 25, 65 cube ends in 25. That means any power of 65, any power of 65 I take, that will end in 25. I don't really need to even check the power. Any other example? So this pattern, as you can see, is only 25, 25, 25. Nothing else is required. Anything else that you want me to check? Any other number ending in 5 raised to any other power? Any other number ending in 5 raised to any other power? So 715 raised to 587. We'll do the exact same thing here. We will check for the base as 15 and then we will try and find out the pattern for this. So 15 into 15, that I kind of remember that square is 225. So this is 15 square. Now let's multiply this with 15. So 5 into 5 is 5, carryover of 1. So this is 125. So the last two digits are 2. Cross here, 1 into 5 is 5. There will be something before it, but I don't care. I am only bothered with what are the last two digits. So 15 cube ends in 75. Then I multiply it with 15 again. So 5 into 5 is 5. 5 into 7 is 35. 35 with a carryover of 2. So 75 cross 5. So this ends in 25. So 15 to the power 4 ends in 25. So now the point that I have been trying to make. So square ends in 25, cube ends in 75, power 4 ends in 25. So this is alternating. So that means 15 to the power, if it is odd or even. If it is odd or even, that is going to define my answer. If it is odd, then my answer will be 75. If it is even, then my answer will be 25. So that is fundamentally the pattern that you need to observe. In this question, what is the power? The power is odd, and that is why the answer here is going to be 75. The answer here is going to be 75. So in case if the number ends in 5, what you need to do is you need to find out the pattern. You need to find out the pattern, and the pattern will be either like the first case where it comes to be 25, 25, 25, or it will be like this case when it is 25 or 75. There is no third case which is possible. There is no third case which is possible. Let's go ahead. Can you quickly solve these two questions? Can you quickly solve these two questions? Preferably without taking too much time. Preferably without taking too much time. First is 25, second is 25 is what Saloni says. Okay, what about the others? Do you have an idea or suggestion for this? Anyone other than Saloni with an answer? $75 and $25 is what Siddharth says. Anyone else? Gaurav says 25. Let's check. So here what we are trying to do is we have 95 first. So 95 into 95. 5 into 5. Then 2. Then I have 75. Anything before that doesn't matter. 95 into 5. So 9 into 5 is 45. So this comes out as 25. So 95 square ends in 25. Let's try and find out for cube. So 5 into 25 will end in 5. 9 into 5 ends in 5. So this is 75. This is 95 cube. Okay. So here I know that it is 25 or 75. So when the power will be even, answer will be 25. Power is odd, answer will be 75. What is the power? The power is even here because it is 68. So 95 raised to an even power will end in 25, and that will be my answer for the first one. The second one is obvious. So 25 square is 625. It will always, whatever is the power given, doesn't matter. It will always end in 25. So answers for both of these will be 25. If you guys are okay with this, I will move on to the next case. Okay. So what happens in the next case when the last digit is 1. So this is another case that I wanted to, discuss with you. So in this case, what you need to do, is whatever is the number. So suppose your number which is given to you is P, Q, R ending in 1 raised to the power of A, B, C, then your answer is going to be last digit of R into C, this one, pick this, and C, last digit of R into C will be the second last digit, and the last digit, as I hope you know, if it is 1, it will always end in 1. So this is what your answer is going to be. Why it is going to be that, I will discuss it shortly, but this is how you are going to get the answer. So say, for example, you have 3791 to the power of 768. Can you now tell me what will be the last two digits for this? What will be the last two digits for this? 21. Saloni is absolutely right. Why will it be that? Because 9 into 8 is 72. 72's last digit is 2. So I get 2, 1. I will write it down just in case, so that in case you don't forget. So 9 into 8, the last digit of that, followed by 1. So I get the answer as 21. 7681. So 1 last digit of 8 into 9, followed by 1, which is again 21. So that's effectively how you can kind of find out what the last digit is going to be. What is also important is to understand why this is happening. And let me just spend a little bit of time on that. So suppose I'm given 3791 to the power of 768. So I have 3791 to the power of 768, and I'm asked to find out its last two digits. Fundamental idea first. Fundamental idea is that for the last two digits in the base, the only thing matters is the last two digits of the base, 91 to the power of 768. Now, is there anyone who knows what the binomial expansion is? What is a plus b to the power of n? So let me just explain that quickly on a slide as well. So suppose, what is the value of a plus b whole square? It is a square plus 2ab plus b square. What is the value of a plus b whole cube? Now, nearly everyone remembers this. Few people remember this. So this is a cube plus 3a square b plus 3ab cube, 3ab square plus b cube. Now, probably very, very few people will remember a plus b to the power of 4. But the idea is you don't need to remember it. So let me tell you how I will calculate it. It will be a to the power 4 plus 4 a cube b plus 6 a square b square plus 4 ab cube. Exactly, Siddharth. That's where I'm getting at. That's what I'm trying to explain. Plus b to the power of 4. Now, if you try to figure out a plus b to the power of n, this is where it gets interesting. So if you are trying to figure out a plus b to the power of n, you very well know that it will start with a to the power n. You also know that it will end with b to the power of n. How many terms will be there? When the power was 2, you had 3 terms. When the power was 3, you had 4 terms. When the power was 4, you had 5 terms. So this will have n plus 1 terms. And what will be those terms? So a to the power n. So this will be a to the power of n minus 1 into b will be there, plus a to the power of n minus 2 into b square will be there. And this will go on till the power of a becomes 1 and the power of b becomes n minus 1. So all possible combos will be there. Say for 4, 4 is here. Then here what is the power? 3 and 1. Then I have 2, 2. Then I have 1, 3. And then finally I have 4. Very similarly, n minus 1, n minus 2, it will go on till 1. Say for example, it is going from 4, 3, 2 and 1. So the same thing or the exact same pattern is going to follow here as well. But what will be the coefficients? So the coefficients in this case will be given by NC1, NC2 for the next term, NC3 for the next term, NC n minus 1 for the second last term, and NC n for the last term. Basically, NCN is 1. That's why it is 1 here and it is NC0 here. So these will be the coefficients. These will be the coefficients. For those of you who do not know, there isn't much to worry about. There isn't much to know. The fundamental idea or the only thing that you need to remember is that the first term, the first one in this case, first one will always be 1, last one will always be 1, the second last one will always be n, and the second one will always be n. So, for example, if someone asks you a plus b to the power of 13, how many terms will be there? Can you now quickly tell me? How many terms will be there? 14. The first term will be a to the power of 14, a to the power of 13. The last term will be b to the power of 13. The second term will be power of a will come down by 1. So a to the power of 12 into b. And here the second last term will be a to the power of 1 and b to the power of 12. Interesting part, what will be the coefficient here? What will be the coefficient here? The coefficient will be n or whatever was the power here. So this will be 13a square b. What will be the coefficient here? It will be 13a b to the power of 12. So this is an application of the binomial theorem. Why did I explain all of this? Because I will try to use it here. So this is 90 plus 1 to the power of 768. How many terms will be there in the expansion? There will be 769 terms in the expansion. What all will be the powers of 90 in it? So the first term will have the power of 90 to the power of 768. The next one will have 90 to the power of 767. The next one will have 90 to the power of 766. So this term, and then these will be multiplied with someone. I'm not saying that these are the final terms. These will be multiplied with something. But whatever they are multiplied with, I don't care. What is my goal? My goal is to find the last 2 digits. Last 2 digits for this will be 0, 0. Last 2 digits for this will be 0, 0 because this is 767 power 0, 0, 0 will come 767 times. Last 2 digits for this will be 0, 0. Which will be the only terms which will not have the last two digits as 0, 0. What about 90 to the power 4? This will have 4 zeros in the end. What about 90 cube into something, whatever it is getting multiplied with, it will have 3 zeros in the end. The terms which will not have 3 zeros in the end will be the term which has 90 to the power of 1 and 90 to the power of 0. So the term which has 90 to the power of 1, it will have 1 to the power of 768, 90 to the power of 0 into 1 to the power of 769. This will be my last term. This will be my second last term. Now, for the last term, what is the coefficient? For the last term, what is the coefficient? The coefficient for the last term is 1, as we have figured out here. The coefficient for the last term for b to the power n is 1 here, it is 1 here, it is 1 here, it is 1 here. What is the coefficient for the second last term? So here it is 2 because the power was 2. Here it is 3 because the power was 3. Here it is 4 because the power was 4. And finally, here it was 13 for the second last term because the power was 13. So in this case, it is going to be whatever is the power. So that is 768. So this is going to be 768. So now, can you tell me what are the the last two digits for this? 90 to the power 0 is 1. So the last two digits for this part are 0, 1. What are the last two digits for this? Last digit is, it's 90 into 1 into 768. So the last digit for this is 0. The second last digit you will get from 8 into 9, or you will get it as 20. And that is how you get 21 as the answer here. So it is not just necessary to know the concept that boss, only thing that you need to do is R into C and the last digit of that followed by 1 is your answer. Please don't do that. Please don't do that. Always try to understand what is going on, what's the logic behind it, what's the reasoning behind it. And based upon that, you can actually find out how to get to the answer. And that's how I've gotten to the answer here. Now, before I finalize this class, let's take just a couple more examples. Can you guys quickly give me any number raised to any power ending in 1 so that I can quickly tell you what the answers are because of this concept? Any number raised to any power ending in 1. Anything that you'd like to give, Siddharth? Or Sundeshwar, who has just joined us, or Fakhruddin? If not, I'll randomly take some examples myself. So tell me, 3751 to the power of 293. What will be the last two digits? 1 will be 1. 5 into 3 ends in 5. So this will be 51. How about 2221 to the power of 333? Last two digits, this will be 1. 2 into 3 will give me 6. So the last two digits will be 61. And that's fundamentally the concept for finding out the last two digits when it is ending in 1. I will take a part 2 or a follow-up of this particular class a little bit later. For now, I'd like to tell you about the scholarship test. If you haven't taken the scholarship test, you can do that right away. There are mock tests. There are small 10-question tests which are conducted every day of the week, not the weekend, where you can win actual prizes on Unacademy. These are the some of the Amazon vouchers, etc. are provided. It also has an Ask a Doubt feature where you can just click a picture and send the doubt for that particular question. In the following class, so I'll have a part 2 of the class. I'll discuss what needs to be done when it is 7 or 9. I'll take a few examples on that. I'll also discuss what to do when the last digit is even. And please follow me on the platform. We will be discussing all of these questions. In case you are planning to register for any of the courses, please use the coupon code HANDA. If you use that particular coupon code, you'll get a 10% off. With that, I'd like to sign off from today's class. Thanks a lot for coming, and I hope to see you guys in my future classes as well. In case you want to get in touch with me for something, please just drop me an email on my email ID, which is ravihanda@gmail.com, which is ravihanda@gmail.com. Thank you guys. That's all for today. Hope to see you soon. Bye, everyone. Bye, guys.